So the takeaway from example 2 mul is that we had the mul-hu being required to get the high X-lang bits of a multiplication, unlike the mul we saw before, which keeps only the low X-lang bits. And it seems to be that GCC recognized that these constants are not going to be ever possibly treated as like signed 64-bit values because they don't have their upper signed bit set. And then it chose to use the mul-hu for unsigned times unsigned multiplication as part of the larger 128-bit multiplication that was going on. And obviously, because we did the 128-bit multiplication, that led to much more complicated code that ultimately had to do, 3 overall multiplications and sometimes, 2 assembly instructions per multiplication in order to calculate the bottom 128 bits of the result that goes back into A and is subsequently returned. Also, I guess another thing you should see is that you did see A0 and A1 being set to the most significant and least significant bits, respectively, of the return value. So you can return an int 128 even though it's bigger than the X-lang register size, and the calling convention of RISC-V is that A0 and A1 are used for return values. A0 is the low bits, A1 is the high bits. Now, if you weren't sure what was going on with this assembly, I did record another optional video that goes line by line in sort of my interpretation of what's going on, and you can watch that next.